Champs of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice your entrance exam question papers because this one and similar type of multiple entrance exam question papers are available there with the detailed PDF solutions. You may also download our app. The link is available in the description box for a better preparation. Students, today we'll be solving EAMCET Engineering 12th May 2023, Shift 1, Physics paper. There are about 40 questions of the paper. You already have seen the mathematical video for the same paper. So in this particular video, I'll be focusing on the physics paper, physics questions. Let's go. Here we go. Question number 81. Best of luck. It says if F1, F2, F3 are the relative strengths of the gravitational, weak, nuclear, and the electromagnetic forces, respectively, then what is the relationship between all of them? Let's say gravitational force be F1, weak nuclear F2, and electromagnetic we have three forces. Now the ratio of the strength of the gravitational force, weak nuclear force, and electromagnetic force there is 1 is to 10 power 26 is to 10 power 36. So you have, this is the weakest one, and this then is F2, and the last one, F3 electromagnetic force, they are the highest ones. So that makes your option B to be the right answer. Hope you understood. Next is question number 82. It says which of the following pairs have same dimensions? I'll pick up like spring constant. If I talk about the dimensions of the spring constant, it is given by force upon length. Units of force are MLT minus 2 upon length is L. So you will have this, the units will be given by MT minus 2. And for the surface energy is given by energy upon area. And what are the units for energy? It's ml square T minus 2. Area is given by L square. So this is equal to, the units are mt minus 2. So these two have the same dimensions. That makes option C to be the correct answer. Hope you understood this as well. Next is question number 83. It says the relation between the time t, distance x of the particle A, which is given by t is equal to ax square plus bx, where a and b are constants and v is velocity of the particle. Then what is the acceleration? You are given in the question. The relation between the time t, distance x of the particle is given by this, where a and b are the constants. If v is the velocity of the particle, then what is the acceleration? So you have the relation as the relation between time and the distance is given to you as t is equal to ax square plus bx. Differentiating both sides with respect to x, you will have dt by dx is equal to 2ax upon b, or you will have dx upon dt is equal to 1 upon 2ax plus b. And you know, this is equal to velocity. So that means these things are equal. Let's say this is number 1 equation. Let's say this is number 1, and let's say this is number 2 equation. So now again, differentiating this with respect to t. Sorry, here it should be t. So this is it. And this will become now d square x upon dt square is equal to, this will be minus 2ax plus b whole square, and here will be 2a into dx upon dt. Let's say this is the third equation. Now putting the value of dx by dt over here, you will have d square x upon dt is equal to, this is 2a, and see, this is equal to v. So I will write it as minus 2a into 1 into v square, and dx by dt, you know, this is v only. So this is minus 2a v cube. That means this is also equal to acceleration. You know, acceleration is the d square x upon dt square. So you have acceleration as minus 2a v cube. This is acceleration. Okay, don't confuse it with this A. So acceleration is equal to minus 2ab cube. That means option C is the right answer. Hope you understood this. Next is question number 84. There's a bomb is dropped on an enemy post on the ground by the aeroplane flying horizontally with a velocity of 60 kilometers per hour at the height of 490 meters. At the time of dropping the bomb, the horizontal distance of the aeroplane from the enemy post so that the bomb hits the target is. So you are having the velocity is given to you 60 kilometer per hour. When the bomb is dropped, it will acquire the velocity of the plane. When the bomb is dropped, so the velocity of bomb will be equal to that of the plane. Bomb velocity is equal to the velocity of the plane. Hence, the initial horizontal velocity of the bomb will be equal to U is equal to UB is equal to 60. This is, wait, UB is equal to 60 kilometer per hour, and the time taken for the bomb to reach the ground will be in the direction, will be taking downwards. So direction will be taken positive. So you have S1 is equal to UB into T plus half AT square. That gives you, here you have S1, let's say, question number 84, a bomb is dropped on an enemy post on the ground by the aeroplane flying horizontally with a velocity of 60 kilometers per hour at a height of 490 meters. At the time of dropping the bomb, the horizontal distance of the aeroplane from the enemy post so that the bomb hits the target is. Okay. So let's see. This is the aeroplane which is flying with the speed of, this is the aeroplane, this is flying with the speed of 60 kilometers per hour. And this is the ground. The distance between the ground and the aeroplane is 490 meters. This is given to you in the question. Now, initial speed of the plane is 60 kilometers per hour. See, the bomb is being dropped. That means it will acquire the velocity of the plane. So bomb velocity will be equal to the velocity of the plane. That is 60 kilometers per hour. That is the initial horizontal velocity of the bomb. Let's say that is equal to ux. This is equal to 60 kilometers per hour. And the time taken for the bomb to reach the ground will be taking downward direction to be positive. So time taken for the bomb to reach the ground over here, time taken by bomb to reach the ground. If I'm taking the downward direction as positive, so this will be given by Sy is equal to Uy plus half Ay t square. Here, Sy is equal to, let's say, h. This will be the displacement in the vertical direction. Displacement in vertical direction. And so here you have Uy as 0 as the initial velocity in the vertical direction is 0, and the Ay is acceleration due to gravity, that is equal to g. So from here you will get h is equal to 0 plus half g t square. That means t is equal to root of 2h upon g. Now height of the particle, height of the aeroplane from the ground is given to you as 490 meters. Therefore, the range of projectile will be range of projectile, that is r is equal to ux into t, that is equal to ux, and t was equal to 2x upon g. And the ux is 60 into, this is in kilometers per hour, right? Let's convert into meters per second because the distance is, height is given in meters. So to change into meters per second, this is has to be multiplied by 5 into 18, multiply 2 into 490 upon g is taken as 9.8. Right, you know the h is equal to 490 from here. So let's solve this. On solving, this is equal to 300 into 10 upon 18, which will give you 500 upon 3 meters. So this is the answer to the question, 500 upon 3 meters. We have option B as the correct answer. Hope you understood. Next is question number 85. It says the angular speed of a particle moving in a circular path is double than the centripetal acceleration of the particle will be. So the centripetal acceleration is given by r omega square. Now you are saying this is omega is your angular speed. So if this is double, so let's say this is the omega dash, this is equal to 2 omega. So the mu acceleration a dash will be given by r into omega dash square, which is equal to r into 2 omega square, or this is equal to 4 r omega square. R omega square was equal to the initial acceleration, so this is equal to 4a. So that means the final acceleration, the centripetal final acceleration will be equal to the 4 times the initial centripetal acceleration. So you have option A as the right answer. Hope you understood. Next is question number 86. Two bodies of mass 1 gram and 4 gram are moving with the kinetic energies, with equal kinetic energies. The ratio of the magnitude of their linear momentum is. Okay, so here you have, you are given that first mass is 1 kg and the second mass is 4 kg. Now you are given that two kinetic energies are equal. Ke1 is equal to Ke2. And what is the formula for linear momentum? This is equal to P is equal to 2m into kinetic energy under the root. So for the first body, Ke1 will be equal to, no, we have to see the linear momentum, right? For the first body, with the mass m1 is equal to 1 kg, linear momentum, this will be given by 2 into m1 into Ke1. And for the second body, it will be given by P2 is equal to root of 2m2 into Ke2. This is equal to 2. First mass is 1, so Ke1. And this is equal to 2 into 4 into Ke2. You are given that these two are equal, so this can be written as 2, or this is 8. This is equal to 8 into Ke1, because Ke and K1, they are equal. So you have this P1 is equal to 2 Ke1 under the root, and P2 is equal to, this can be written as 2 root 2 Ke2, 1 Ke1. Ke1. So what you have to find out is the ratio of their magnitude. So that means you have to find out P1 is to P2, which is equal to this upon this. So this is equal to 1 by 2. That means this is 1 is to 2. That means P1 is to P2. The ratio of the linear momenta is 1 is to 2. Let's check with the options. Option C is the right answer. Hope you understood this. Next is question number 87. The displacement S of a body of mass 3 kg under the action of a force given by T. S is equal to T cube upon 3, where S is in meters and T is in seconds. The work done by the force in 2 seconds is. So you have S is equal to T cube by 3. Or ds, let's differentiate both sides with respect to t. You will have this as 3t square upon 3, or this is equal to t square only. And you know ds, the change in displacement with respect to time, this is nothing but your velocity. So you have velocity as t square. Also ds by dt is equal to t square. And let's differentiate again. You have ds upon dt as t square, or the second derivative is equal to 2t, which is, this is acceleration. The second derivative of the displacement with respect to time is acceleration. What you have to find out in the question was work done by the force in first 2 seconds. So work done by the force in first 2 seconds, it will be like from 0 to 2. This is the time of force into displacement into dt. That means force is equal to M into A, and D is your S in this case. D is, yeah, okay. And this is multiplied by dt from 0 to 2. Or this is equal to, the mass is given to you as 3 kg, and S is equal to 3q by 3. Let's fill in all the values. So you have 3 into acceleration is 2t, and displacement is t cube upon 3 multiplied dt from 0 to 2. I'll take 3 outside, 0 to 2, and this will be, okay, these two things will cancel, and here I should write 2. This will be 2 power 4 dt, or this is equal to 2 power 5 upon 5. Here will be 2 from 0 to 2, or this will be equal to 2 into 2 power 5 upon 5 minus 0, or this will give you, yeah, so this is equal to 2 into 7. The displacement test of a body of mass 3 kg under the action of the force, which is represented by this equation, where S is in meters and T is in seconds. What is the work done by the force in first 2 seconds? You are given the equation S is equal to T cube upon 3. And also you have mass is 3 kg. So let's differentiate it with respect to t. So you have ds by dt is equal to 3t square upon 3, or this is equal to t square. That means this is equal to v. See, ds upon dt, this is equal to v. So you have ds upon dt is equal to v is equal to t square. One thing, again differentiating it with respect to t. So you have d square s upon dt square as 2t, and this is acceleration. So d squared s upon dt square is equal to a is equal to t. Now I have the acceleration and I have the velocity. What you have to find out is work done in the first 2 seconds. So work done in the first 2 seconds, this will be given by integration from 0 to 2 f into ds. And what is ds from here? ds is equal to t square into dt. So this is equal to 0 to 2, and f is equal to mass into acceleration into t square into dt, or mass is 3, acceleration is 2t into t square into dt, 0 to 2 limits. This will be 3 outside, this will be 0 to 2. Actually, this will be 6 outside. And here will be t cube into dt, or you have 6 t power 4 upon 4 upon limit 0 to 2. Or you have 6, this is 2 power 4 upon 4 minus 0. That's 6 into 2 power 2, or that is equal to 24. Okay, so this is the answer to the question, 24 joules. Option D is the right answer. Hope you understood this. Next is question number 88. A system consists of two particles M1 and M2. And if the particle M1 is moving towards the center of the mass through a distance d1, then the center of the second particle should be moved so as to keep the center of the mass at the same position. Therefore, sorry, I have to... Question number 88, a system consists of two particles M1 and M2. If the particle M1 is moved towards the center of the mass through the distance d, then the second particle should be moved so as to keep the center of the mass at the same position. So that means the center of the mass will not change. It will remain 0. Okay, anyways, so let's see, you have these two masses. Let's say this is mass M1 and M2, and this is their center, CM, center of the mass. So let's say this is x1 and x2. What are x1 and x2? Let's write down. Let x1 and x2 are positions of first and second mass. Positions of M1 and M2 respectively. Then the position of the center of the mass will be given by M1 x1 M2 x2 divided by M1 plus x M2. Now, if x changes, by delta x1. Then xm will change as delta xm will be equal to m1 delta x1 plus m2 delta x2 divided by m1 plus m2. This is 1. Now you are said that the center of the mass doesn't change. So you have delta x according to the question. Delta x cm is equal to 0. And this is equal to d. These two things are given to you. So let's fill these things in this equation. You have 0 is equal to m1 into d plus m2 into delta x2. Or you have delta x2 is equal to minus m1 into d upon m2. This is what we needed. We need to know by how much distance the second mass should be moved so that the center of the mass doesn't change. That is minus md upon m1d upon m2. So you have option C as the right answer. Hope you understood this. Next is question number 89. If the radius of the Earth becomes x times its present value, then what will be the new period of rotation? Okay, so see, if the radius of the Earth changes to x times, first of all, you know the radius of the Earth is given by r. Radius of Earth is given by r and mass is m. Now, if the radius becomes new radius is equal to xr. Now, by the conservation of angular momentum, by conservation of angular momentum, you have I1 omega 1 is equal to I2 omega 2, where I is moment of inertia of sphere. Moment of inertia of sphere. And this is given by 2 by 5 m r square. Right. And also one thing, this is your angular velocity, angular frequency, which is 2 pi upon t. So let's fill in the values in this, both of these values, this and omega in this equation. You had I1, omega 1 is equal to I2, omega 2, or you have 2 by 5. Here is the mass of the Earth is given as capital M, m into r square, and this is 2 pi. Initial one is 24 hours, and this is equal to 2 by 5 m. Now the radius becomes equal to n times, no, it is x times square into 2 pi. Let the time period be t now. These two things will cancel, and 2 pi will also cancel. Here you have r square is equal to r square upon 24 hours is equal to x square r square upon t. R square will cancel, and you have t is equal to 24 x square. So this is the new time period for rotation, that is 24 x square. Option C is the right answer. Hope you understood this. Let's move to the next question. Question number 90. For a particle executing simple harmonic motion, the kinetic energy of the particle at a distance of 4 centimeter from the mean position is 1/3 of the maximum kinetic energy. The amplitude of the motion is. Fine. First of all, maximum kinetic energy is given by half Ka square, where K is the amplitude. And for a particle which is given as which is executing a simple harmonic motion, the maximum kinetic energy is given by this, and the particle kinetic energy of the particle at the distance of 4 centimeter from the mean position, this is given by, this kinetic energy is given by half of k into a square minus x square. Now in the question that it's given that this is equal to 1/3 of this. According to the question, Ke is equal to 1/3 Ke max. Or you have half K A square is equal to 1/3 half K A square minus this. So these two things, this will cancel. You have a square, 3a square is equal to a square minus x square, or you have x square is equal to okay, you have 2a square is equal to x square. Sorry, I did a mistake. This is wrong equation. Ke is equal to 1 by 3 of k max. So let's do this one again. This is 8. Okay, ke is equal to this. This is equal to 1 by 2 into ka square minus x square is equal to 1 by 3. Ka max is this. So now let's do the cancellations. These two things will cancel and you have 3a square minus x square is equal to a square, or you have 2a square is equal to 3x square, or you have a square is equal to 3 by 2 x square. Now you are given the x is equal to 4 over here. And this is equal to 3 by 2 into 4 into 4, or this gives you a is equal to root of 3 into 2 into 4, or this is equal to 2 root 6. So you got the amplitude as 2 root 6 centimeters. Option A is the correct answer. Hope you understood that. Let's move to the next question. On a wire of length 40 centimeters stretched by 0.1 centimeter, the strain on the wire is. So here you have the wire length as 40 centimeters and elongation or stretch or elongation is equal to 0.1 centimeter. Strain will be given by elongation upon length. So this is equal to 0.1 upon 40, or this is equal to 1 upon 400, or this gives you 25 into 10 raised to power minus 4. That means you have A option as the right answer. Hope you understood that. Let's move to the next question. Question number 92, a straw of circular cross-section of radius r, negligible thickness, is dipped vertically into a liquid of surface tension T. If the contact angle between the liquid and the straw material is 53 degree, force acting on the straw due to the surface tension on the liquid is, you are given cos 53 is 0.6. So you are given that the radius of cross-section of straw is r and the surface tension of liquid T. Also, contact angle is equal to 53 degree and cos 53 degree is equal to 0.6. Now we know that force due to surface tension is given by F is equal to T into 2 length plus thickness multiply cos of angle between them. So this is equal to, see, you are given the thickness is negligible. So negligible thickness, that makes the thickness as 0. So this is equal to 2 into L cos theta. L is equal to 2 pi r. Length is equal to 2 pi r cos 53 degree. So T into 4 pi, this is capital R over here. So capital R, and cos 53, this is 0.6 multiply. On solving, this will be T into 4 pi R, 6 upon 10. This will give me 12 pi RT upon 5. So this is the answer to the question. We have option A as the correct answer. Hope you understood this. Next is question number 93. Solid metal sphere released in a vertical liquid column has attained terminal velocity in the downward direction. The magnitude of the viscous force, buoyant force, gravitational force acting on it are given by these three respectively. Then what is the correct relationship between them? All right. So terminal velocity, first of all, let's talk about what is that. It is velocity, highest velocity that is obtained by an object falling through the liquid. Highest, it is terminal velocity is the highest velocity obtained by a liquid, by an object, sorry, freely falling through a liquid. So you are given, this is your buoyant force, this is your viscous force, and this is your gravitational force. These three forces are given to you. Among these forces, only the gravitational force acts in the downward direction. At the terminal velocity, you have at terminal, that is the highest velocity, you have gravitational force is equal to the sum of viscous and buoyant force. So this is the maximum one at the terminal velocity. So this is equal to option B. Here you have the correct answer. Hope you understood this. Next is 94 question. Two objects made of same material have masses m and 2m and are at temperatures 2T and T respectively. When a heat Q is supplied to the object of mass 2m, its temperature rises to 2T. And if the same heat is supplied to object of mass m, the temperature rises to what? Okay, so you have to find out when the same temperature is heat is applied to the object of mass m, what will the temperature then, how much it will rise. So you are having the mass of the two bodies. This is the first and the second body. The mass of the first body is m and the second body is 2m. Here the temperature is 2T and the temperature is T. So using the formula, heat is equal to mc delta T, where C is your specific heat, delta T is change in temperature, and Q is the heat given or supplied. Right? For the second body, the mass this and heat is T. Okay, when the temperature is rises to 2T, so this is your initial and this is your final temperature for the body of mass of second body. So for second body, heat for second body Q, it is given by m into C into delta T. Here m is equal to 2, it was 2m, mass is equal to 2m into C and delta T, it rises from T to 2T. So this is 2T minus T. This is equal to 2m into C into T. That is equal to your Q, or C is equal to Q upon 2. Wait, change in temperature, it rises to 2T, right? So this will be 2T only. Wait. So here will be 4 MT. This is equal to Q upon 4 MT. So this is the value of C. See, value of C for the first one also remains the same, right? So here you have Q is equal to MC delta T. This is for the first body and this was for your second body. So here the same Q heat is applied. So Q is equal to this delta T. This is equal to C, or C is equal to Q. M remains M, and the change in temperature, that I don't know what is there. So let it be delta T only from 1 and 2. Obviously, specific heat is same. So Q upon M delta T is equal to Q upon 4M into T. Q, M, M. This will cancel, and you will have delta T as 4T. So that's it. You have 4T, option C as the right answer. Hope you understood this. Let's move to the next question then. Question number 95. On a temperature scale, on a new temperature scale, the melting point of the ice is this. Boiling point of the water is this. At a temperature of 40 degrees Celsius would be indicated on this new scale as which one of these? Okay. See, from the standard scale, at 0 degree, this is the freezing point of water. Freezing point of water at 100 degrees, it boils. Boiling point of water. You know this. This is as per your standard scale. Okay. Now, according to the question, new scale has a 20 degree X. as melting point and 100 degree X as boiling point. So from these two equations, these two and these two, if I combine them, that means 100 degree for this water, 100 degrees Celsius is equal to, see over here, this is 110 degree X. Question number 95, on a new temperature scale, the melting point of ice is 20 degree X and the boiling point is 110 degree X. The temperature of 40 degrees Celsius would be indicated on this new scale as, okay, see, for your standard scale, you know the freezing, the lower fixed point, and there is an upper fixed point. The lower fixed point is the freezing point, and that is 0 degrees Celsius, and the upper fixed point is your boiling point, that is 100 degrees Celsius for, okay. And for this particular scale, you have lower fixed point. This is the melting point of ice or the freezing point, whatever you want to say. So this is freezing point, and this is 20 degree X. And you have the upper fixed point, which is the boiling point, that is 110 degree X. So we know one formula, that reading on any scale minus the lower fixed point divided by the upper fixed point minus lower fixed point, it is constant for all the scales. That means it will be same. This constant will be same for both of these scales. Okay, so that means you have, if I take this, the new temperature for the X minus lower fixed point is 20 divided by 110 minus 20 is equal to the upper fixed point reading on any scale. This is for 40 degree, I want to know. So you have 40 minus 0 upon 100 minus 0. That makes X minus 20 upon 90 is equal to 40 upon 100. Or you have X minus 20 is equal to 40 into 90 upon 100. Or this is equal to 36. That gives you X is equal to 56 degree. Okay, so this X is equal to 56 degree, and the units were X for this. So you have option B as the correct answer. Hope you understood this. Next is 96th question. The percentage of heat supplied to a diatomic ideal gas that is converted into work in an isobaric process is, see, for an isobaric process, you have the pressure constant. You have a constant pressure. So for the constant pressure, heat supplied for constant pressure, the heat supplied is given by this formula. Here N is number of mole of ideal gas, and this is your specific heat at constant pressure, and this is change in temperature. Delta T is change in temperature. Now work done in isobaric processes, work done in isobaric process is given by delta W is equal to P into delta V. You know one formula, that PV is equal to nRT. Using that, nR T2 minus T1, this is equal to delta W, or you have delta W as nR delta T. So the ratio delta W upon delta 2 using this and these two equations. This is equal to nR delta T, and this was equal to NCP delta T. So this gives you R upon Cp. So you know, for the diatomic gas, Cp is equal to 7 by 2 R. So let's put this in this equation. You have delta W upon delta Q is equal to r upon 7 by 2 into r, or this is equal to 2 by 7. This is equal to your work upon heat. Now, percentage of conversion will be percentage of conversion 2 by 7 into 100. This will be 28.6, approximately 8%. That makes option C to be the correct answer. Hope you understood this. Next is question number 97. Ratio of translational degrees of freedom to rotational degree of freedom for a polyatomic linear gas molecule is. See, for a polyatomic gas, translational degree of freedom is equal to 3. For polyatomic gas, transitional sorry, this is a translational degree of freedom is 3 and the rotational degree of freedom is 2. Vibrational degree of freedom, this is 1. So required ratio is a ratio of translational degree to rotational degree. This is 3:2. That makes D as the right option. Hope you understood. Next is 98 question. A ring has a mass m and radius r. The distance of the point in its geometric axis from the center at which the gravitational field is strongest is. So you have the mass of the ring as m and radius r. We have to calculate the distance from its geometrical axis. So let's make this something like this. This is the ring with the radius r. So here you have the point P. This is x. Now gravitational field is given by the point P as a gravitational field at point P will be given by EP is equal to gmx upon r square plus x square power 3 by 2. Let's say this is equation 1. So to get the maximum value of EP, we have to find the derivative. For the maximum value of EP, we have to do the derivative of EP with respect to x. And for the maximum value, this derivative will be equal to 0. That means gmx upon r square plus x square, this should be equal to 0, right? Or, sorry, I have to find out the derivative. Wait. Let's do this thing. R square plus x square raised to power 3 by 2. I have to find the derivative of it. Let's do this way. This is equal to 0. And this gives you r square plus x square cube. And here you will have a into 3 power 2 into gm x will not be there, minus gmx into 3 by 2 r square plus x square into 2x. This is equal to 0. This 2 and 2 will cancel, and more cancellations will be there. Let's solve this. You have r square plus x square, and I'm taking the gm constant. So minus x 3x square minus 3x square r square plus x square. Here was power 3 by 2. And here I have taken gm outside. Whole divide. This is equal to 0. So because this cannot be equal to 0, so this is definitely equal to 0. Let's gm, this can't be 0. I'm also taking r square plus x square outside. This is root of r square plus x square minus 3x square is equal to 0. This also cannot be 0 because both are squares and none of them is 0. So this cannot be 0. This makes you root of r square plus x square is equal to 3x square. Squaring both sides, you have r square plus x square is equal to 9x square. Question number 98. A ring has a mass m and radius r. The distance of the point in its geometric axis from the center at which the gravitational force is strongest is. So you have two things. Mass is equal to m, radius r. Now we have to calculate the distance from its geometric axis. This is the geometric axis. This is the ring. And this is the center. This is its geometric axis. Let this be the point P. And this is x, the radius of the ring, it's r. Okay, now gravitational field at P point is gravitational field at point P is given by EP is equal to gmx upon this. Let's say this is equation 1. Now to get the maximum value, the gravitational field to be the strongest, let's find out the derivative of it. For maximum EP, I will say dEP upon dx is equal to 0 or d of gmx upon r square plus x square power 3 by 2 is equal to 0. We have gm out. I'm going to take it outside because this is constant. And this is derivative of x upon this is equal to 0. This cannot be equal to 0. So that means this is equal to 0. So you have denominator square, denominator part 3 by 2 into derivative of numerator minus x into r square plus x square 3 by 2 minus 1 into 2x. This is equal to 0. So this is r square plus x square into root of this minus 2x square. Yeah, this is equal to r square plus x square power of 1 by 2, or you can say this is under the root. This is equal to 0. Again, taking the root outside common. Inside you will have r square plus x square minus 2x square. See, there is 3 by 2, right? So it has to be multiplied with 3 by 2 over here also. This 2 and 2 will cancel. This will be 3x square. This is equal to 0. So obviously you have r square plus x square minus 3x square is equal to 0, or you have r square is equal to 2x square, or x is equal to r upon root 2. This is the answer to the question. X is equal to r upon root 2. We have D as the right answer. Option D is the correct answer to the question. Hope you understood this. Let's move to the next question there. Next is question number 99. A heavy uniform rope is suspended vertically from a ceiling and it's in equilibrium. A pulse is generated at the bottom end of the rope as shown. As the pulse travels up the rope, its acceleration at any point is given by, where g is the acceleration due to gravity. So, okay, let's say m is the mass of the rope and this is the distance L. Let's say, okay, first of all, what is the speed of wave on the string? It's given by V is equal to root of T upon mu, where T is the tension, mu is linear mass density, and m is the mass of the rope. So from here, mu is the linear mass density. This is given by mass upon length. So let's fill in all these value in the given equation. This one you have V is equal to root of T is mg and mu is m upon L. This will give you root of GL. All right. Now using the equation of the motion, we have V square is equal to U square plus 2AS. Let's write again. V square is equal to U square plus 2AS. We know this is equation of motion. So here you have V as 0 because the rope is connected to ceiling. Rope is connected to ceiling. Therefore, you have A as U square upon 2S. U is given by G into length and S, this is actually the length of the rope. So you have S is equal to L. That gives you A is equal to acceleration is equal to G by 2. That means the value of acceleration remains constant. So this makes option constant and equal to G by 2, option A to be the right answer. Hope you understood. Next is question number 100. A wave is given by this equation, then the velocity of the wave is, you have to take y and x in meters and t in seconds. So wave equation in this question is given by y is equal to 0.02 sine pi x minus 8 pi t. Correct. Now comparing this equation with the standard wave equation, which is this. So if I look at both of these equations, you have A as 0.02, K is equal to pi, omega is equal to 8 pi. So the velocity will be given by omega upon K. This is equal to 8 pi upon pi. That is equal to 8 meters per second. So you have C option as the right answer. Hope you understood. Next is question number 101. Question number 101. An empty tank has a concave mirror at its bottom, as its bottom. When the sunlight falls normally on the mirror, it is focused at a height of 32 centimeter from the mirror. If the tank is filled with water up to a height of 20 centimeter, then the sunlight focuses at, you have to take the refractive index of the water to be 4 by 3. Now, certain things are given to us in the question. Let's write them clearly. First of all, you have in the question, it's given image distance is 32. Since it's made in the negative opposite direction, so I'm taking image distance V as minus 32 centimeter, and the object, because here the object is sun, so object distance is infinity. You are given that tank is filled up to 20 centimeter. Also refractive index of water is equal to 4 by 3. Okay, so water, let's write on water here. Yeah. So next, I'll be using the mirror formula. Using mirror formula to get the focus of it. So 1 by F is equal to 1 by V plus 1 by U, or you have 1 by F is equal to minus 1 by 32 plus 1 by infinity. That gives you F is equal to minus 32 centimeter. And when the water is filled up to a height of 20 centimeter, when water is filled up to 20 centimeter, let's say that is H, the image formed by mirror, by this concave mirror. It's given in the question. This is your concave mirror and this is the sunlights which are, sun rays which are falling over here. This is your 20 centimeter water level and here is the image formed. Now this is at 12 centimeters. Because this is totally 32, right? 20 from here and 12 from here. Okay. All right. So the image formed by the mirror. This is your concave mirror. This is what I was talking about. This is your mirror. So image formed by the mirror will act as virtual object for water surface. Okay. So the image formed by the virtual object, image will be formed by the virtual object. This will be refractive index of water upon air. This is equal to actual height upon apparent height. And the refractive index of water, it's given to you 4/3. For air, it is 1. So this is equal to actual height. Actual height is your, if I'm taking this O and let's say this is X. So OX is equal to 12. This is OX upon XI. So this is equal to OX is 12, XI will be equal to 12 upon 4 into 3, or this is equal to 9 centimeter. So sunlight will focus at 9 centimeter above the water level over here. This will be the point. That means we have B as the correct answer. Hope you understood this. Let's move to the next question. 102. When Young's double slit experiment is performed in here, the y-coordinate of the central maximum and the 10th maxima are 2 and 5 respectively. If the apparatus is immersed in a liquid of refractive index 1.5, the correspondingly y-coordinates will be. See, for the Young's double slit experiment, YDSE apparatus in air. You have two things. First of all, you are given for the central maxima, n is equal to 0. For central maxima, n is equal to 0, and you have y0 upon into d upon capital D minus d sine theta is equal to 0. That gives you d cancelling out. D is not equal to 0. That makes y naught upon d minus sine theta is equal to 0, or sine theta is equal to y naught upon d. And for the 10th maxima, for 10th maxima, you have n is equal to 10. Or same thing, you have y10 into d upon d minus d sine theta is equal to 0. Sorry, is equal to 10 lambda. And okay, one thing I have I've been given this value y10 is equal to 5. Also, this is equal to 2 by 5, because I was given that for central maxima, it's 2, and for the 10th maxima, the y coordinate is 5. So this makes it 5 y10, that is equal to 5 into d upon d minus d sine theta is equal to 10 lambda. So let's put in the value of sine theta from here in this equation. 2 upon capital D is equal to 10 lambda, or this will be 3 d upon capital D is equal to lambda, or you have lambda is equal to 3d upon 10d. Hope you got till here. Next, this apparatus in liquid. YDSE apparatus in liquid with refractive index 1.5. N is equal to 1.5. For central maxima, this for central maxima, you have n is equal to 0, or y naught dash upon d minus d sine theta is equal to 0. As the y coordinate of the central maxima doesn't change upon changing the wavelength, therefore it will remain same in air and the liquid as well. So that means y naught dash is equal to y naught is equal to 2. Actually, this is y0. So y naught y0 dash is equal to y naught y0 is equal to 2 for the 10th maxima. Wait. For the 1/10th maximum, you have the same thing, y10 dash small d upon capital D minus d sine theta is equal to 10 lambda upon the refractive index, which is equal to 1/5. And y10 dash into d upon d minus d sine theta is equal to 10 upon 1.5. The value of lambda was equal to 3d upon 10, 3 small d upon 10 capital D. So this gives me, also I have the value of sine theta as this 2 upon capital D. Let's fill all the values. You have y dan dash into d upon d minus d into 2 upon capital D. This is equal to 10 upon 15 into 10 into 3 upon 10 into d upon d. So this 10 and this 10, this will cancel 5 and 2. Taking d by d common from here, you have y10 dash minus 2 is equal to 2 into d upon d. This is d. These things will again cancel. So you will have y10 dash minus 2 is equal to 2, or y10 dash is equal to 4. We already had yes, y0 dash is equal to 2 and y10 dash is equal to 4. So that makes 2 and 4. Option C. This is the right answer. Hope you understood this. Let's move to the next question then. Question number 103. A clock dial has point charges which are given by minus Q, minus 2Q, minus 3Q, minus 12Q, and so on till minus 12Q at the position of the corresponding numbers on the dial respectively. The time at which the hour's hand points the direction of the net electric field at the center of the dial. You have to assume that the clock does not influence the net electric field. So this is the clock given to you, and all the numbers, these are the charges, respective charges at the points. This is drawn. So this is the direction of the electric field. The net electric field due to the oppositely faced charges will be in the direction of, see, if I'm seeing this one, look at this one carefully. Wait. So if this, I'm looking at the first one, this will go to 7. This will be the line. Wait, I'm not drawing it. Let's zoom it a bit. So from here, a straight line will go something like this till here, right? So net electric field due to oppositely faced charges would be in the direction of, obviously this is the bigger charge, so it will be in this direction, minus Q and Q, because they are entirely in the opposite direction. So net electric charge will be given by minus 6Q in the direction of minus 7Q. How did you get minus this? Because this will be minus 7Q minus of minus Q. This will be minus 6Q in the direction of minus 7Q. Similarly, if I take the another one, that is 2 and 8 over here, same thing will happen. Magnitude minus 8Q minus of minus 2Q. This is equal to minus 6Q in the direction of minus 8Q. Similarly, minus 6Q in the direction of minus 9Q, so on till minus 7Q. Okay, so let's write it properly. Minus 6Q magnitude of charge in direction of minus 7Q, minus 8Q, minus 9Q, minus 10Q, minus 11, and minus 12Q. All right. So this is I'll pick up now these are the resultant directions. I think now we can ignore if I'm having this clock. Now I'll be ignoring this. Wait, let me make the clock first. 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is the center. Now only I'll be considering these directions. So only these 6 directions will be considered, because we have resolved all these positions. 1 to 6 positions have been resolved. We are left with minus 7q from here to till 12. Okay, these positions will be left. Now, resultant of minus 7q, minus 8q, and minus 9q would point in direction of minus 8q, right? If I'm considering this and this and this, these three these three electric fields I'm considering, the net will, because they are in the vectors, the net will be in the direction of 8q only, minus 8q. And from here, similarly, if I'm considering these three, 10, 11, and 12, the net electric field will be in this direction. Resultant of minus 10q, minus 11, and minus 12q would point in the direction of minus 11q. Right? Now I'm left with minus 8q. These two directions I'm left with. One is this. Let me make the clock again. So now these two directions will be left. 11 and 8. 9, 10, 11. 11 and 8. These two directions will be left. So resultant of minus 11q and minus 8q, it will be the mid of it. And the mid of it will be in the direction of 930. In the direction of 930. Right? So if I'm looking at this, the mid will be this. It will come something like this. That makes option B to be the correct answer. Hope you understood this. Let's move to the next question, number 104. The electric potential at a place is varying according to this equation. Then the electric field at x is equal to 1 meter and y is equal to 1 meter is. Okay, so you are given the electric potential. This is V half y squared minus 4x. So E is given by this I minus this. And let's find out this with respect to x. You will have a half into 4, that is equal to 2. And dy by dx, dv by dy, this is equal to half into 2y, or this is equal to y only. So this will be equal to minus 2 I cap minus y j cap. Here was minus, so this is supposed to be, sorry, not a minus over here, it will be minus over here. So this will be minus and minus 2. Question number 104, the electric potential at a place is varying for this equation. Then the electric field at x is equal to 1, y is equal to 1 meter is given by. So you're given electric potential by this equation, half y square minus 4x. Let's find out the derivative, dy by dx. This is equal to half into minus 4, that is equal to minus 2 also. Sorry, dv by dx, and the dv by dy is equal to, this is equal to half into 2y, or this is equal to y. And the electric field is given by dv upon minus dv upon dx I cap minus dv upon dy. j cap. So this is equal to minus of minus 2 I cap minus and y j cap. This is 2 I cap minus y j cap. At x is equal to 1 and y is equal to 1 meters, you have E as 2I minus j. So this is the answer to the question. 2I minus j volt per meter. Option C is the correct answer. Hope you understood this. Next is question number 105. When a potentiometer is connected between the points A and B as shown in the circuit, balance point is obtained at 64 centimeter. When it is connected between A and C, balance point is 8 centimeter. If the potentiometer is connected between B and C, what will be the balance point? Okay, let's zoom the figure a bit to see. So these are the points A, B, and C. Potentiometer, when it is connected between A and B, the balance obtained is 64 centimeter. Let's write down potentiometer between A and B. Between A and B, then you have balance point as 64 centimeter. And when it is between A and C, balance point is 8 centimeter. You have to find out between B and C. When the potentiometer is between B and C, then you have to find out what is the balance point. Okay. See, when potentiometer led at B, move towards C, balance obtained, wait, between A and C, it is 8. Fine. So, potentiometer difference, potential difference is V is equal to K into L, where K is your potential gradient. Okay, so now I'm using both of these things. You have V1 is equal to KL1. This is equal to 64K. And V2, this is V1 minus V2. This is equal to 8K. See, when the potentiometer, it is led at B, move towards C. From here, it's moving towards C. It is question number 105. When a potentiometer is connected between the points A and B as shown in the circuit, balance point is obtained at 64 centimeter. When it's connected between A and C, balance point 8 centimeter. If the potentiometer is connected between B and C, the balance point will be at. Okay, so potentiometer is connected across A and B, then balance obtained is 64 centimeter. When potentiometer led at B move towards C, then balance is 8 centimeter. Now the potential difference is V is equal to KL, where KL is your potential gradient. And let's say this is equation 1 and equation 2. From equation 1, you have V1 is equal to K into L1, which is equal to 64 into K. And from equation 2, you have V1 minus V2 as 8K, or you have 64K minus V2, 8K. And V2 is equal to K into L2. So this becomes first of all, V2 is equal to 64 minus 8, that is 56K, or you can write it as KL2 is equal to 56K, or you have KL2 is equal to 56 centimeters. So here you have option B as the correct answer. Hope you understood. Next is 106 question. In the given part of the circuit, the potential at point B is 0 and the potential at A and C respectively are. So here you have the point. This is A, B, and C. The direction of current from A to B, which means A is at higher potential. This is the direction of the current. So A is at higher potential. For the section, wait, everything is going late. So now for section AB, you know, V is equal to IR. I is the current is 1 ampere and the resistance is this. So 1 into 1.5. So V is plus 1.5 volt at A. Now for the section BC, you have V is equal to IR. At C, let's say the potential is X. Okay, so this becomes 2V, because here you have 2V, voltage is 2V plus X is equal to IR. So from here you have I is equal to 2V plus X upon the resistance is 2.5 ohm from here. And right now from diagram, you clearly have that I is equal to 1 ampere. So for I to be 1, the V upon R ratio should be equal to 1. That gives you 2.5 is equal to 2 plus X, or X is equal to 0.5. Sorry, there's a mistake small. This was 1.5 V. So this is equal to, I'll resolve this thing. You have 1 is equal to 2 into 1.5 plus X upon 2.5. This gives you 2.5 is equal to 3 plus X, or X is equal to minus 0.5 volt. That makes option D to be the right answer. Hope you understood this. Next is question number 107. A conducting wire PQ carries a current of 10 ampere as shown in the figure. 10 ampere as shown in the figure. It is placed in the uniform magnetic field 5T, which is acting normally outside from the paper. What is the net force experienced by it? Okay, let's see the figure first carefully. Let's zoom. So if I draw a line from straight line from P to Q over here. From here, you are given in the question PQ carries 10 amperes of the current and magnetic field is 5T, which is normal to the plane of paper. Normal to the plane of paper. So if I take this PQ and let's say this is O, let's go to find out the length of PQ. I'm applying the Pythagoras theorem. This is 6, so this much will be 3 and 3. So this length will be equal to root of 4 square plus 3 square, which is equal to 5. Similarly, this is also equal to 5. So that means PQ comes out to be 10 centimeter. Hope you are clear till here. Now the force experienced by the wire in uniform magnetic field is given by Pi L sine theta here, because it is perpendicular, so theta is equal to 90 degree, and you are given that B is equal to 5, current is 10, length we just calculated, it is equal to 10 centimeter. I have to convert it into meters, so this will be 0.1 meters. This is equal to 5 into 10 into sine into L, this is 0.1 and sine 90 is equal to 1. That gives you 5 Newton. So the force is 5 Newtons. You have B option as the correct answer. Hope you understood. Next is question number 108. A long straight wire carries a current of 18 ampere. The magnitude of the magnetic field at a point 12 centimeter from it is. So you are given here that the current in long straight wire is 18 amperes. Distance from wire where magnetic field is to find is 12 centimeter. Is 0.12 meters using Ampere's law for straight line. Using Ampere's law for long straight wire, you have B dl that is equal to mu naught I, or you have V is equal to upon 2 pi r. So let's put in all the values. So you have B is equal to mu naught is 4 pi into 10 power minus 7. Current is 18 upon 2 pi, and you're having the distance from the wire from the R is equal to this 0.12. So let's solve this. 4 pi and pi, like 2 and 2. So you have 2 into 18 into 100 into 10 power minus 7 upon 12. So you have this as 3 into 10 power minus 7 t. So you have option C as the correct answer. Hope you got that. Next is question 109. A bar magnet has a curiosity of this much. It is placed inside a solenoid of 12 centimeter length and 60 turns. Current that should be passed through the solenoid to demagnetize the bar magnet is. So you are given that coercivity of bar magnet. It's given by this ampere per meter. You have 60 turns and length of 12 centimeter. Now number of turns per unit length in meter. Number of turns per unit length in meters is given by N is equal to N upon L, 60 upon 12 into this, or this is equal to 500 turns per meter. A magnetic intensity of H, of magnetic intensity H of equal magnitude as curiosity is required to demagnetize the bar magnet. So you have H is equal to N into I. That means 4 into 10 power 3 is equal to 500 into I. Or you will have 4 into 1000 upon 500 is equal to I. That is equal to 8 amperes. So that means you have D option as the correct answer. Hope you understood this. Next is question number 110. When a current I through a solenoid is increasing at a constant rate, then the induced current is. Question number 110. When a current I through a solenoid is increasing at a constant rate, then the induced current is. Over here in the question, the current flowing through the solenoid is increasing at a constant rate, then magnetic field associated with magnetic field associated with the solenoid is given by P is equal to mu naught N I. Let's differentiate both sides with respect to T. So you have dB by dt is equal to mu naught N into di upon dt. You are given that it is increasing at a constant rate. Current is increasing at a constant rate. So that means this is equal to 0 because di upon dt is constant. Sorry, this is equal to constant. It's increasing at a constant. It is increasing, but at a constant rate. So this is equal to constant. So these two are already constant. If these two are constant, and this is also constant, that means dB by dt is also constant. Now flux is given by dot product of B and A, and d phi upon dt is equal to A into dB upon dt. Here is your area. Now, you know, this thing is already constant and A is also constant. That again means that change in flux is constant. So the current induced is also constant. Whenever there is change in flux, the body tries to oppose this change by inducing the current in the opposite direction. So it is constant and it will be in the direction opposite to that of the current. That makes B option to be the correct answer. Hope you understood that. Next is question number 111. In a pair of adjacent coils, if the current in one coil changes from 10 to 2 ampere in 0.2 seconds, an EMF of 120 volt is induced in another coil. The mutual inductance of the pair of coils is. So, okay. What is a change in current? Current change, that is delta I is 8 amperes. And you have the time as 0.2 seconds. Induced EMF that is equal to 120 volt, and then using Faraday's law of mutual induction, you have magnitude of E is equal to change in the flux, or flux is M into delta I. Here M is your mutual inductance of pair. Mutual inductance of the pair. So you have E is equal to M delta I upon delta T. Let's say that's equation 1. So if I'm putting all the given values, all these values in this equation, so you will have 120 is equal to M into change in current is 8, and change in time is 0.2, that is equal to M is equal to 120 into 2 upon 10 into 1 upon 8, or this will give me 3H. This is the answer to the question. Option B is the right answer. Hope you understood this. Next is 112 question. The power factor of an AC circuit containing peak current of 2 amperes, peak voltage 1 volt is half, 1 by 2. Then the angle between voltage and current is. Let's write down, you have peak current as 2 amperes, voltage 1 volt, peak voltage is 1 volt, and you have the power factor as 1 by 2. You know, power factor is equal to peak voltage upon peak current. So also this is equal to 1 by 2. So yeah, according to this also, this is 1 by 2. And power factor is also equal to cos of angle between voltage and current. So this is half is equal to cos of theta, and theta taking the angle between voltage and the current. So this is possible. Theta, cos of theta is equal to cos inverse 1 by 2, or this is equal to 60 degree. So this is the answer to the question. Option D is the right answer. Hope you understood this. Next is 113 question. If a plane electromagnetic wave has an electric field oscillations of frequency 3 gigahertz sorry, 3 gigahertz, then the wavelength of the wave is, you have to take the speed of light in vacuum as 3 into 10 power 8 meter per second. So you are given the frequency as 3 gigahertz. But this is equal to 3 into power, this is 3 into 10 power 9 hertz. Also, speed of the light is this. So electromagnetic wave, which is traveling with the speed of light, is given by electromagnetic wave traveling with speed of light is given by C is equal to V into mu into lambda. So the lambda is your wavelength, and this is the, wait, I'll write it here. And mu is your frequency. So you have lambda is equal to C upon V, or this is equal to 3 into 10 power 8 upon 3 into 10 power 9. That gives you lambda is equal to 0.1 meters. So you have first option as the correct answer. Hope you understood. Let's move to the next question then. Question number 114, the de Broglie's wavelength of an electron accelerated between two plates having potential difference of 900 volt is nearly dash. De Broglie's wavelength associated with electron accelerated with a potential difference V is given by lambda is equal to h upon p. So p is given by linear momenta. This is given by 2m into kinetic energy. So you have E is equal to E into V, where E is the charge and V is potential difference. Let's fill in the values. So now this equation will be lambda is equal to h upon root of 2m into E into V. Let's say this is equation 1. So let's fill in the values which we have. You will get h, m and E. Know that values. H is your Planck's constant with the value of, this is 6.63 into 10 power minus 34 joule second. And m is the mass of the electron, which is equal to 9.11 into 10 power minus 31 kg. And E is the charge on the electron. That is equal to 1.6 into 10 power minus 19 coulombs. So I'll fill on the values. You have lambda is equal to h is 6.63 into 10 power minus 34 divided by root of 2 into 9.11 into 10 power minus 31 into 1.6 10 power minus 19 into the voltage, which is equal to 900. Okay, so on solving this, you will have a 6.63 to 10 power minus 32, and this will be the root of 29.12 into 10 power minus 50 into 900. So 6.63. What is the root of 29.12? It is, on solving, it is 5.4 into 10 power minus 34 upon 10 power minus 25 into 1 upon 30. So this is, this will give you 1.23 into 10 power minus 9 into 1 upon 30. I'll keep 1 upon 30 as such. This will be 0.04 nanometers, 10 power minus 9 nanometers. So I have converted this into the nano. So this is the answer to the question, 0.04 nanometers. You have option D as the correct answer. Hope you understood this. Let's move to the next question, number 115. If an electron is moving in the fourth orbit of the hydrogen atom, then the angular momentum of the electron in SI units is. You are given in the question, electron is moving in the fourth orbit of hydrogen. So according to Bohr's postulate, angular momentum is integral multiple of h upon 2 pi. So you have L is equal to NH upon 2 pi as electron is moving in the fourth orbit. So you have N is equal to 4. So this becomes L is equal to 4 into this, 4 into pi upon 2 pi. That is equal to, sorry, here was H, not pi. So this is equal to 2H upon pi. This is the answer to the question, 2H upon pi. Option B is the correct answer. Hope you got that. Next is 116 question. The energy equivalent to mass of 1 kg is. Okay. Energy equivalence of a mass. If I talk about the equation, you know that E is equal to mc squared, where m is the mass of the object and c is the speed of light. Mass of object and this is speed of light. You're given that mass is equal to 1 kg in the question itself, and you know speed of light, this is equal to 10 into 3 into 10 power 8 meters per second. So the energy will be given by 1 into 3, 10 power 8 square. This will be equal to 9 into 10 power 16 joules. So you have C option as the correct answer. Hope you understood. Next is question number 117. If S is the surface of a nucleus of a mass number A, then which of the following is true relation about S and A? So mass number of nucleus is A. Mass number of nucleus is A and the surface area of nucleus is S. If I use the relation R is equal to R naught raised to power R is equal to R naught multiply A raised to power 1 by 3. That means radius is directly proportional to the third the third root of mass number of the nucleus. Nucleus is spherical in shape. That means the area is given by 4 pi r square. So you can say that S is equal to 4 pi r naught a power 1 by 3 whole square. So that means this is 4 pi r square a power 2 by 3. And so this means that surface area is directly proportional to a power 2 by 3. So you have D option as the correct answer. Hope you understood. Next question number 118. In a transistor, the base current is 10 microampere and the emitter current is 1 milliampere. Then the collector current is, so you have the base current as 10 microampere and emitter current IE as 1 milliampere. This is base current. I'll keep it and IB. If I convert it, this is equal to 1000 microamperes. In a transistor, you know that emitter current is equal to base current plus collector current. So this is your collector current. All right, you just have to fill in the value. So IC is equal to IE minus IB. So this is equal to 1000 minus 10 microamperes. That is equal to 990 microamperes. So you have first option as the correct answer. Hope you understood. Next is question number 119. If the output of a NAND gate is given to a NOT gate, what is the resultant gate? Let's make the NAND gate first. This is your X and Y, and they are fed input to a AND gate. Right? Like this. There it is. NAND gate. So AND gate product are result is X dot Y, and when I put a NOT gate towards it, this will be XY bar. Now this is fed as an input to a NOT gate. This is the NOT gate, and NOT gate just reverses the result. So this will be X dot Y. This is nothing. This whole circuit is nothing but an AND gate. So we have first option as the correct answer. See, AND gate gives you the result as x dot y. So you got the result as x dot y when you are feeding in two inputs as x and y. So this is nothing but your AND gate only. Hope you understood that. Let's move to the last question of the physics paper. Question number 120. A message signal of frequency 10 kilohertz is used to modulate a carrier wave of frequency 6 megahertz. Then the sideband frequencies are. Carrier frequency here is 6 megahertz. Carrier frequency 6 megahertz, or this is equal to 6000 kilohertz. Message signal frequency. Message signal frequency is 10 kilohertz. Let's say C be the carrier wave frequency, be the carrier wave frequency, and M is the message signal frequency. So upper side band is given by upper side band is given by C plus M, that is 6000 plus this, which is equal to 6010 kilohertz. And lower side band is frequency is given by minus this is equal to 5990 kilohertz. Final sideband frequency (6010 kilohertz) and 5990 kilohertz. That makes, let's check with the options. That makes option B to be the correct answer. Yeah. Hope you got that. So students, with that, we have completed all the physics questions for the paper. And don't forget to visit our website, www.examsnet.com. There you will find all the entrance exam question papers with their detailed PDF solutions for your practice. You also must download our app. The link is available in the description box for a better preparation of your exams. So students, keep shining, keep rising high. That's all for this one. Bye. Hey, champs of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice your entrance exam question papers because it has so many papers along with the PDF solutions for your preparation. Also, you must download our app. The link is available in the description box for a better preparation of your exams. Students, today in this video, I'll be solving EAMCET Engineering 12 May 2023, Shift 1 paper. In this particular paper, I'll be solving only the chemistry portion. For the mathematics and the physics to explore our website and the videos. So, very best of luck. Here we go. Question number first for the chemistry section. It says the radius of third orbit of a hydrogen atom is r picometers. The radius of the second orbit of helium ion in picometers is. So you have these two things. First is radius of the third orbit of the hydrogen atom is rpm, and this is what you have to find out. These two things are there. So I'll be using the formula r is equal to n square upon z into 0.529 angstrom. So this is given to you in the as r in the question. So r is equal to n is third orbit, so it is 3 square, and z is the atomic number of hydrogen. It is 1 into this. So this becomes equal to 9 into, I'll convert into picometers because you are asked the question in picometers, and the radius is also in picometers. So this is equal to 52.9 picometers. Let's say this is equation 1. So you have to find out radius of second orbit of helium ion. So x of helium ion is given by helium is like second orbit, so it is 2 square.
upon Z. Z is 2. For helium, the atomic number is 2. So Z is equal to 2. Multiply by 52.9. This is equal to, okay, let's say this is equation 2. So from both of the equations, let's divide them. From both equations 1 and 2, you have R upon X is equal to 9 upon 9 into 52.9 multiplied by 2 into 52.9. Or you have this as R is equal to X into 9 by 2. Or X is equal to 2 by 9R. This is the answer to the question. 2 by 9R. Option D is the correct answer. Hope you understood this. Next is question number 122. The threshold frequency of a metal is 10 power 15 per second. The ratio of the maximum kinetic energies to the of the photoelectrons when the metal is made to strike with the radiations of this frequency and this frequency respectively are. You have the threshold frequency as this 10 power 15 per second. First frequency is given by this 1.5 into this. And the second frequency 2.0 this per second. You have to find out ratio of maximum kinetic energy of these photoelectrons. So maximum kinetic energy for the first and second one. This is what you have to find out using the equation of photoelectric effect. The equation of photoelectric effect, you have HV is equal to HV naught plus kinetic energy, or kinetic energy is equal to this. So you have to find out KE max for the first and the second. Wait, KE max. This is given by H. Now V was equal to 1.5 into, for the first one, you can say V1. So this is 1.5 into 10 power 15 minus 1 into 10 power 15 divided by H into 2 into 10 power 15 minus 1 into 10 power 15. H will cancel. And here is 0.5 into 10 power 15. And here is 1 into 10 power 15. Or this is equal to 0.5, or this is equal to 1 by 2. So the ratio is equal to 1 by 2. That means you have second option as the correct answer. Hope you understood this. Next is question number 123. You have to consider the following. The order of, okay, you have to read down all of them and then check which of the following are correct. The correct statements are. Let's go. First one. Order of first ionization enthalpy of first three elements of third period is magnesium, followed by aluminium, followed by sodium. First one is correct. See, the order of first ionization enthalpy of the first element, first three elements of the third period is definitely given by this. This is right. The second one, the element with electronegativity of 3.5 is chlorine. No, electronegativity of chlorine is 3. It's not 3.5. So this is wrong. Third one, the order of sizes of ions, magnesium 2 plus, sodium plus, fluorine negative, oxygen negative is given by highest is oxygen, then fluorine, sodium, then magnesium. This is correct. Exactly, this is right. Next, the last one. The IUPAC name of element with the atomic number 116 or 106 is borium. This is wrong. No, the IUPAC name of the element with the atomic number 116 is vinyl hexium. So 1 and 3 are correct. That makes C option as the right answer. Hope you understood. Next is question number 124. You have to match the following. So here is the molecule or ion, and this is, we are talking about their shape. Okay. First one is tin chloride. Here you have the bond pair, and here you have the lone pair. And for this one, you have the bond pair as 2 and the lone pair as 1. So its shape is angular. It matches with third one. Then is ammonia, bond pair 3, lone pair 1. Therefore, its shape is trigonal pyramidal. Fourth one. Next is the iodide iron, and its bond pair is 2 and the lone pair is 3. Its shape is linear. Here the last one, that is SO3, it is having the bond pair as 3 and the lone pair, there is no lone pair, so it's trigonal planar. A1. So looking at that, you have A matches with 3, B matches with 4, C with 2, and D with 1. That makes D as the right answer. Hope you got that. Let's move to the next question. Question number 125. In which of the following set of molecules the hybridization of central atoms is different? Okay. Water, NH3, methane, and this, and this. If I pick up the fourth option, the set of molecules given in the option D has different hybridization of central atoms, that is SF4, XEF4, and CH4. For SF4, this is equal to 4 plus half of 6 minus 4, that is equal to 4 plus 1. So you have the hybridization of sp3d. And the next one, XEF4, this is 4 plus 1 by 2, 8 minus 4. So you have 4 plus 2. So this is square planar. Hybridization over here is sp3d2. Next, you have CH4, that is equal to 4 plus 1 by 2, 4 minus 4, that is equal to 4 only. So here the hybridization sp3. So these set of molecules have different hybridization of central atoms, and D option is the correct answer. Hope you understood this. Next is question number 226. At 300 Kelvin, 760 torr pressure, the density of mixture of helium and oxygen gas is this. The mass percent of oxygen approximately is equal to what? You have to take the value of R as this. We know the formula that the Pm is equal to dRT, where this is your molecular mass. D is your density. So you have 760 upon 760. 760 upon 760 into M is equal to, density is given to you as this. Yeah, it is this. 0.543 into R is 0.821 into T, temperature is 370. Okay. You know, 1 atmosphere is equal to 760 torr. So here I have done the conversion of torr to atmospheres. Okay. So here you have M is equal to, on solving this whole thing, you will get 13.37 grams per mole. Let the mole fraction of oxygen in mixture be Y. So you have for oxygen is equal to Y, and for helium, this will be obviously 1 minus Y. Then you have average molecular weight as Y into M of O2 plus 1 minus Y, molecular mass of helium. So Average molecular mass we just saw, this is equal to 13.37. This is equal to Y into 32 because 16 oxygen molecular mass is 16 into 2, 32 plus 1 minus Y, and for helium it is 4. This will give you 13.37 is equal to 32Y plus 4 minus 4Y, or you will have here 28Y is equal to 9.37, or you'll get the value of Y as 0.335. So, percentage mass by mass of oxygen is equal to 0.335 into 32 up to 100, because I have to calculate the percentage, divided by 0.665 into 4 plus 0.335 into 32. Okay, this is what is that? Mole fraction of helium. This is the mole fraction of oxygen. This is the molecular mass of oxygen. This is the molecular mass of helium. And on solving this whole thing, you will get the percentage as 80.12%, which is approximately 80% only. That means the percentage by mass of oxygen is 80%, option B. Hope you understood that. Let's move to the next question. Equivalent weight of which of the following is maximum? You are given the atomic weights for sodium, manganese, chromium, potassium, oxygen, and carbon as these ones. So the first element, this is Na2 C2O4.H2O. So you have 2 sodium atoms, 2 into 23 plus 2 carbon plus 4 oxygen and 2 molecules of water. Water is 18. And this is divided by 2. So this on solving will give you 170 upon 2, that is 85 gram. Like this. And the second one, KMnO4 H plus. So this is equal to 39 plus 55 plus 4 into 16 divided by 5. That's equal to 31.6 gram per equivalent. Or the third one is KMnO4H2O. This is equal to 39, 55, 64 upon 3. That is equal to 52.6. And the last one, you have K2Cr2O7H plus, this is equal to 2 into 39, 2 into 52, 7 into 16 divided by 6. The value is 294 upon 6, or this is equal to 49. So, which is the highest one? Obviously, 85. That makes first option as the correct answer. Hope you understood that. Let's move to the next question. Question number 128. If 2.5 moles of ideal gas at certain temperature are allowed to expand isothermally and reversibly from initial volume of 2 dm cube to 20 dm cube, the volume, the work done by the gas is minus 16.5 kilojoules. The temperature in Kelvin of the gas is. So you have to round off your answer and you have to take the value of R as this. So you are given in the question that N is equal to 2.5 moles and the V1 is 2 dm cube. V2 is 20 dm cube. Work done is this. And if I convert this is in the kilojoules, so this is equal to 16.5 into 10 raised to power 3 joules, and the gas constant is 8.314 joules per Kelvin per mole. And what you have to find out in the question is the temperature. Okay, so I'll be using the formula W is equal to minus nRT into log of V2 upon V1. Or this is equal to minus 16.5 into 10 power 3 is equal to minus 2.5 into 8.314 into T multiplied by log of this, natural log of this. So you have T as 16.5 into 10 power 3 divided by 2.5 into 2.303 into 8.314. Or this is equal to 344.7 Kelvin, which is approximately 345 Kelvin. That makes option C as the correct answer. Hope you got that. Let's move to the next question. Question number 129. The solution is prepared by mixing 10 ml of 1.0 m acetic acid and 20 ml of 0.5 m sodium acetate diluted to 100 ml. If pKa of acetic acid is 4.76, then what is the pH of the solution? The solution is obtained by mixing the given data is an acidic buffer. The expression used for finding the pH of the acidic buffer is given by expression used for finding pH of acidic buffer is given by pH is equal to pKa log of concentration of salt to acid. And you are given this is equal to 4.76. Let's write down this is 4.76 and the concentration of salt is let's calculate that. So this is yeah, over here this is 0.5 ml and 20 ml of the solution divided by 100. This will be equal to 0.1 m. And for the concentration of the acid, you have this is 10 ml of 1.0 moles of the acetic acid per liter solution. So this into this upon 100. This is equal to 0.1 m again. So the pH is equal to 4.76 plus log of 0.1 upon 0.1, which is log of 1, that is equal to 0. Log of 1, this is equal to 4.76. So this is it. You have first option as the right answer. Hope you understood. Let's move to the next question. Question number 130, consider the following statements about hydrides, and you have to choose the correct statements. Okay. Let's read the first one. It says sodium hydride with water liberates oxygen gas. Let's write down the reaction. Sodium hydride, when it reacts with water, it liberates sodium hydroxide in the aqueous solution and the hydrogen gas. This is solid and this is, of course, aqueous. So now the question, oxygen gas, no, it releases hydrogen gas. So this is wrong. It does not release oxygen, it releases hydrogen gas. So this one is incorrect. Second one, methane, silane are examples of electron precise hydrides. This is absolutely correct. Third one, ammonia and water molecules are examples of electron deficient hydrides. Let's see. Ammonia and water molecules are examples of electron deficient. No, they are electron rich compounds. That makes third one to be the wrong one. Next, the last one, hydrides of beryllium and magnesium are polymeric in structure. This is correct. So that means you have the second and the fourth one to be the correct answers. So C is the right answer. Option C. Next is 131. The nitrate of which of the following metals does not liberate nitrogen dioxide gas on heating? First is lead, then is beryllium, lithium, potassium. Okay. The nitrate of potassium metal on heating liberates. Let's do that. KNO3 on heating. This is in the solid form. On heating, this liberates sodium nitrite and oxygen gas.
Which of the following metals does not liberate nitrogen dioxide gas on heating? So the first one is lead. It's lead nitrate. On heating, it will evolve lead oxide, nitrogen dioxide, and oxygen. Let's do the balancing. Here is 2, 2. Here should be 4. This is lead nitrate. So, okay. Here, the nitrogen dioxide, this is evolved. The second one, barium nitrate. This gives you barium oxide, nitrogen dioxide, and oxygen, the same thing. 2, 4, and 2 over here. So again, you have the nitrogen dioxide over here, lithium nitrate. This gives you lithium oxide, 4NO2. This is 4, and here will be 2, plus oxygen is evolved. You have the nitrogen dioxide as the product. Next, the last one, potassium nitrate. On heating, this all on heating. This gives you potassium nitrite plus oxygen. Here, no nitrogen dioxide is evolved. So you have D as the right answer. Hope you understood this. Next is question number 132. So you have to list, match the following, list one substance, and this is the use. So Na2O2, this is Na2O2, this is the oxidizing agent. This is an oxidizing agent, then D2O, this is moderator. And CS is photoelectric cells, magnesium hydroxide, this is antacid. So the correct answer, A matches with 3, B with 4, C with 1, and D with 2. That makes the option A to be the right answer. Hope you understood this. Next is question number 133. What are the correct statements about the elements of group 13 given below? Okay, the first one says the stability of +1 oxidation state follows the order. That's thallium. Question number 133. What are the correct statements about the elements of group 13 given below? First one, the stability of the +1 oxidation state follows the order thallium, indium, gallium. This is right. Second, boron has the lowest melting and boiling point as it is a non-metal. No, it is a high. It is high boiling and the melting point. Third one, boron shows a maximum covalency of 4 in its compounds, right? Fourth one, the order of atomic radius of gallium, aluminium, indium is this. This is again wrong. This is right, wrong. This is right. And this order is given by gallium less than aluminium less than indium. So atomic radii increases down the group, but atomic radii of gallium is less than that of aluminium due to the presence of d electrons. So this is the right order. And means fourth one is also. Last one, aluminium is passive to concentrated nitric acid. That's correct. So you have 1, 3, and 5 as the right answers. That makes option A as the correct one. Hope you got that. So next is question number 134. Assertion says graphite is used as dry lubricant in machines which run at high temperatures. Yeah, that's right. Next one, the layers of graphite slip over one another when the pressure is applied. This is also correct. So that means assertion is correct and the reason is a correct explanation of the assertion. You have option C as the right answer. Next is question number 135. You have to tell the IUPAC name of the compound given over here. Let's zoom it a bit. So this is the compound. Let's say this is 1. Here it is 1, 2, 3, 4, 5, and 6. So according to this, the IUPAC name is given by, you have 2 bromo, 1 ethyl, 4 nitrobenzene. That makes B as the right answer.
Hope you understood. Next is question number 136. Which are the following hyperconjugation is not possible? Hyperconjugation is not possible in the compounds in which alpha hydrogen is absent. Okay. Thus, this compound, this compound does not have the alpha hydrogen, and this shows hyperconjugation. That makes A option as the right answer. Hope you got that. Next, number 137. So this is the first reaction. This is the first one and the second reaction. Here the functional groups in X and Y are respectively. Let's write on the first reaction. You have CH3, 2CH, double bond CH2. This reacts in the presence of KMnO4 hydrogen ions. It gives you CH3, CH3 plus carbon dioxide plus water. And if I do the second one, this is CH3, CH3. This again in the presence of KMnO4 H plus ions. This gives you 2CH3COOH. So this is your X and this is your Y. What is the functional group in X? This is CO. So this is the functional group in X and this is COOH. So it can be written like this, CO. Wait, this makes OH. Okay, so this is yeah, that makes, which is the right answer. Here you have B. This is the right answer to the question. Hope you got that. Let's move to the next question then. Question number 137. This is the first reaction and the second one. So you have to find out what comes in the place of X and Y in both of these equations. Let's write on the first reaction. You have CH3, 2, CH2. This in the presence of KMnO4 H plus. This gives you CH3CO. CH3 plus carbon dioxide plus water. And the second one, you have CH3, CH3. This again in the presence of KMnO4 hydrogen ions. This gives you 2CH3COOH. This is your X and this is your Y. So X has, you have to find out the functional groups in X and Y. So H has, this is C, like this. So this is the functional group in the X, and for the Y you have CH3COOH. So this is your okay, if I write it like this, it is this is the functional group. This is why. So according to this one represents this particular ones represents your C, or over here also C. So these are, this option B is the right answer. Hope you got that. Next is question number 138. Identify the major product B in the given sequence of reactions. So let's write on the reaction first. I'll write it myself. You have CH3, C, triple bond, CH in the presence of hydrogen. And this you have, this is propene. And this is your element A. Now this reacts in the presence of hydrogen bromide, C6, H5CO, 2, O2. This reacts to gives you CH3, CH2, CH2, Br. This is 1-bromopropane. Okay, so this is your B product. The major product B in the given sequences. This is the major product B, and this is CH3, CH2, CH2Br. Option B. Okay, so this major product will be formed as per Markovnikov's addition. Markovnikov's reaction. So next is question number 139. At temperature in Kelvin, copper, whose atomic mass is this, has FCC structure with the edge of length x angstrom. The density of copper in gram per cubic centimeter at the temperature approximately is, you have to take the value of Na as this much. So here you have the edge length as x angstrom and the atomic mass of calcium 63.5 units for FCC unit cell, that is Z is equal to 4, you have to find out the density. So the formula density is equal to Z into M upon EQ into Na. So the atomic number, that is Z, is given to you as 4 and the M is 63 point, atomic mass is 63.5 divided by 6.0 into 10 raised to power 23. That is the value of Na given. And then you have AQ. A is this much. Let's do the units conversion also. This is x into 10 raised to power minus 8 cube. This will be equal to 4 into 63.5 divided by 6 into 10 power 23 into x power 3 into 10 power minus 24 gram per cubic centimeter. So the density is equal to this, on solving, will be upon 6 into x cube, or this is equal to 423 upon x cube gram per centimeter cube. That makes option C to be the right answer. Hope you understood that. Next is question number 140. The vapor pressure of the pure liquid A is 70 torr at 300 Kelvin. It forms an ideal solution with another liquid B. The mole fraction of B is 0.2. Total vapor pressure of the solution is 84 torr at the same temperature. Vapor pressure of the pure liquid B in torr is, vapor pressure of the pure liquid A is 70 torr at this much temperature. So you have vapor pressure of pure A 70 torr, and you are given this is equal to 0.2, right? The mole fraction of B is 0.2 and the total pressure of the solution is 84 torr. So you have the total pressure is 84 torr. What you have to find out? Vapor pressure of pure B. So this is what you need to find out. Okay, now we know that thing that total, the mole fraction of A and B is equal to, of A and B is equal to 1. So if I'm giving for A, that means this is equal to 0.8. Also from the Dalton's law of partial fraction, Dalton's law of partial pressure, you have total pressure is equal to, for A, pressure for A plus B. Using Raoult's law for component of A and B, using Raoult's law for A and B component, you have PA is equal to this. And that means this is equal to, this is 70 into 0.8, that is equal to 56. Let's say this is 1, 2. Also, pressure B is equal to multiply by XB, that is equal to PB naught into 0.2. Let's say this is equation 2. So substituting the value of 2 and 3 in this is equation 3. Substituting the value of 2 and 3 in this equation, what you will get is total pressure is given to you as 84. This is equal to, that was equal to PA plus PB. This is equal to 56 plus 0.2 multiplied by pressure of B at pure, like pure B. This one, the vapor pressure of pure liquid B. This is equal to 84, or PP naught is equal to 84 minus 56 divided by 0.2. This is equal to 140 torr. So this is the answer to the question, 140 torr, option A. Hope you got that. Next is question number 141. The electric potential of chlorine electrode is maximum when the concentration of chloride ion in the solution in mole per liter is X. What is the value of X? Okay. In general, reduction potential of non-metal electrode increases with decrease in the concentration of the electrolyte. Reduction potential of non-metal electrode increases with decrease in concentration of the electrolyte. Therefore, the concentration of chloride ion in the solution will be concentration of chloride ion in solution. This will be the minimum one. Okay. So you have A as the right answer. Hope you understood. Let's move to the next question. 42, the benzene diazonium chloride undergoes first order decomposition at temperature is given in Kelvin with the constant, with the rate constant of this much. The time for completion of 90% of the reaction in minutes is nearest integer. You are given the value of log 2 and log 3, which will be used in the question. See, this is the first order decomposition. So you have n is equal to 1. This is first order decomposition. Also, you are given the rate constant 6.93, 10 power minus 2 per minute. Right. So also you have A as 100 minus X, or 100, or A minus X is equal to 10. It's given to you. So this is the time for the completion of 90% of the reaction. So A minus X is equal to 90%. You have to find out the time required. Using the formula for the rate constant of the first order reaction. Formula of rate constant for first order reaction, you have T is equal to 2.303 divided by K log concentrations. This and this. So 2.303 divided by 6.93 into 10 raised to power minus 2. And this is equal to 100, initial one, and this is 10. So you have 2.303 upon 693 into 10 power 2 log 10, which is equal to 1. So 2.303 upon this. Let's solve this now. This will give you 33.23 minutes. That is approximately 33 minutes only. Log 10 is equal to 1. And let's check with the options. You have C as the right answer. Hope you got. Next is 143. Identify the factors which favor the physical adsorption from for the following. First one, high surface area. Okay, that's right. Low temperatures, right? High temperatures, no. Low pressure, no. High pressure, yes. So high pressure, low temperatures, and high surface area. These things are right. These are the conditions which favors the physical absorption. So you have B as the right answer. Hope you understood that. Question number 144. Sphalerite, siderite, malachite are the ores of XYZ metals. What are the atomic number of them? Okay, the first one, sphalerite, is zinc sulfide. The second one, siderite, is FeCO3, and then is malachite, Cu2, CO3, OH2. So here the atom, zinc, iron, and copper. What is the atomic number of zinc? 30, 26, and this is 29. So 30, 26, and 29, option A is the right answer. Next is question number 145. You have to consider the reaction. This is the reaction given to you. You have to identify the reaction in which Q is not the product. Okay. So first of all, you have to find out what is Q. Let's write down the reaction. You have P4 plus 3 NaOH and 3 water. This gives you PH3 NaH2 PO2. Let's do the balancing. So you have 3 over here. You have, I think all the balancing is done. Right. So this is your Q. That means you have Q as PH3. All right. And what you have to find out is among all these reactions, which does not give you PH3 as a result. So if I pick up this one, the last one, PCl3, if I reacted with the water, it will give you H3PO3 along with your hydrochloric acid. So let's do the balancing. This is 3 and here will be 3. Yeah, it's done. So among the following options, product Q is not obtained in option D. If I see rest of the options, let's see this. The first one, it's right on the equations. You have a question number 145. Consider the reaction P4 plus 3 NaOH plus H2O gives you Q and this product. So you have to identify the reaction in which Q is not the product. So this is Q, and you have to identify which of these reactions does not give you this product. First of all, to answer the question, I need to know what is Q. For that, let's complete the equation. You have a P4, 3 NaOH plus 3 water. This gives you PH3 NaH2PO2. Let's do the balancing. Here is 3, here should be 3, and the rest is balanced. So this is your Q. That means you have to identify which of the reaction does not have PH3. Let's pick up the first one. You have Ca3P2. If I react it with water, according to this equation, you will get PH3 plus calcium hydroxide. Let's do the balancing. Here will be 6 and 2 and 3. So here you have PH3. The Q is present. The second one, when I heat H3, PO3 on heating, it will give me PH3 plus H3PO4. Do the balancing again. So now it is balanced. It has the Q element. Third one, PH4I, when reacts with potassium hydroxide, it gives you PH3 plus hydrogen iodide plus water. So again, you have the PH3 in this. Let's go for the last one. You have PCl3 plus water. On heating, on reaction with water, it gives you H3PO3 plus 3HCl. So here is the balancing. I don't have a PH3 over here. So you wanted to have the reaction in which Q is not the product. That means D is the correct answer. Hope you understood this. Next is question number 146. The oxidation states of sulfur atoms and number of SOH bonds in peroxydisulfuric acid are respectively. See, the formula for peroxydisulfuric acid is H2S2O8. Its structure is given by SOOSOH double bond O, double bond O. Similarly, double bond O, double bond O, and OH. From the structure, we can clearly see that oxidation state for both the sulfur atom is plus 6, and it has 2 SOH bonds. That makes C to be the correct answer, right? Next is question number 147. You have to identify the correct statements from the following. First one says, this gold is soluble in aqua regia but not in platinum. This is, no, this is wrong. See, gold and platinum both are soluble in this aqua regia. Okay. Question number 147, you have to identify the correct statements from the following. First one, gold is soluble in aqua regia, but not platinum. No, both are soluble in aqua regia. So this is wrong. Gold and platinum both are soluble in this. Next, among the oxa acids of chlorine, highest oxidation state possible for chlorine is +7, right? That's correct. Among the hydrogen halides, lowest boiling point is for hydrogen chloride. That's also right. Last one, the order of stability of oxides of halogens is given by this. No, this is wrong. The order of stability of oxides of halogens is given by, first is iodine, then bromine, and then chlorine. So this is the right order. So these first is wrong and the fourth is wrong. That means second and the third one are correct. That makes B option to be the right answer. Hope you understood that. Next is question number 148. So this is the chemical reaction given to you. Xenon and fluorine, they at 573 Kelvin under the pressure of 60 to 70. No pressure. This is this is bar, not something. Wait. There is a pressure of 60 to 70 bars. You get the product X. And then when X reacts with water, it gives Y and hydrogen fluoride. And when it reacts with 3 molecules of water, it gives you Z and hydrogen fluoride. So you have to identify the statements, correct statements about Y and Z. To answer the question, I need to complete the equations first. So xenon, when reacts with chlorine at 573 Kelvin, pressure of 60 to 70 bars, you will get Xe, F6. This is distorted octahedron. Now, XeF6, when reacts with water, it gives you XeOF4 plus hydrogen fluoride. So this was your X and this is your Y product, right? And the same XeFe6, when reacts with 3 molecules of water, it gives you XeO3. This is your Z and trigonal pyramidal and 6 molecules of hydrogen fluoride. Okay, so that means you have, this is your Y and this is Z. Thus, let's talk about the statements. First one says the Y has square pyramidal geometry. That's right. And second, Y has linear geometry. No, second one is incorrect. Because see over here. Okay, Y we are talking about. See, Y has square pyramidal geometry. It does not have a linear geometry. So the first one is right. The second one is wrong. The third one says you Z has 3 omega 3 pi bonds and 1 lone pair of electrons on the central atom. Let's make it. So here you have xenon, double bond O on the 3 sides and 1 lone pair. So this is 3 omega bond. It has 3 omega bonds. So this is 3 pi bonds and 1 lone pair. 3 pi bonds and 1 lone pair. So This is right. So, the third one, it's also right. Let's go for the fourth one. Z has tetrahedral geometry. No, it does not have a tetrahedral geometry. So 1 and 4, they are, sorry, 2 and 4, they are wrong. And yeah, you have the first and the third one as the correct ones. First and third, that is option A. Hope you got that. Next is question number 149. The number F electrons in +3 oxidation state of gadolinium, Z is with atomic number is 64, is X, and in +2 oxidation state, yttrium, atomic number 70 is Y. The sum of X and Y is. See the electronic configuration of GD, that is gadolinium, is 64. Atomic number is 64. So GD 64, this is xenon 4F7 5D1 6S2. And when I remove 3 electrons from it, this will be equal to Ze4F7. So in the +3 oxidation state, you have X is equal to 7. Okay, and let's go for the second one. YB with atomic number 70, you have this as Xe4 F14 and 6S2. In the +2 oxidation state, so I'll remove 2 electrons from here. YB +2, this will be Xe4 F14. So you have Y is equal to 14. X plus Y, X was equal to 7 and Y 14. So X plus Y is equal to 21. That makes option D to be the right answer. Hope you understood this. Next is question number 150. So you have to match the following. This list has to match with this list. Let's go. So the very first one. So this is a complex and electronic configuration of the metal ion is given by. Okay, the first one, let's see. Okay, so CO NH3 6 3 plus. This is this one. It matches with option 2. The second one, COF6 3 minus. This matches with third one. And nickel NiCO4. This matches with this one. FeCN6 3 minus. This is option A. So A matches with 2, B with 3, C with 4, and D with 1. That is first option. Hope you got that. Next is question number 151. Amongst the following, how many of them come under the category of elastomers? Natural rubber, polythene, vulcanized rubber, bakelite, polyvinyl chloride, buna N, nylon 6, or neoprene. See, among the following elastomeric polymers are, first of all, what are the elastomeric polymers? These are the polymers, these are the polymeric chains which are held together by the weakest intermolecular forces. Elastomeric polymers are those polymeric chains that are held together by weakest intermolecular forces. So among the given ones, first of all, natural rubber, vulcanized rubber, buna N, and neoprene. These 4 are the elastomeric polymers. So you have option A as the right answer. Hope you got this. Next is 152 question. Which of the following is incorrect statement about maltose? Maltose, it's a reducing sugar. That's right, it's a reducing sugar. It is composed of 2 alpha D glucose units. That's correct. It's composed of 1 beta D-glucose and 1 beta D galactose unit. No, that's wrong. Maltose, no, this C1 is wrong because it is composed of 2 molecules of alpha D glucose units only. So that means this one is incorrect. It has 1,4 glycosidic linkage. That's also right. Option C is wrong. Next is 153, which of the following is not correctly matched. First one, butylated hydroxytoluene antioxidant in food. This is rightly matched. The next one, chloramphenicol antiseptic. No, that's not. See, chloramphenicol is an antibiotic used in the treatment of bacterial infections. So it is not an antiseptic used bacterial reactions. The next one, northindrone, antiphylactic drug, that's right. And elitame, artificial sweetener, that's also correct. So we have C option as the correct answer. Next is question number 154, which of the following is the least reactive towards SN2 reaction? Okay. See, the order of reactivity towards SN2 reaction for alkyl halide is given by, first is methyl. Let's write down. Order of reactivity towards SN2 reaction for alkyl halides is given by, first of all, methyl primary halide. Question number 152, which of the following is correct statement about maltose? Number one, it's a reducing sugar, right? It is composed of 2 alpha D glucose units. That's correct. Composed of 1 beta D glucose and 1 beta D galactose unit. No. Option B is correct. It is composed of 2 alpha D glucose units. So that means this C is wrong. Next, it has 1,4 glycosidic linkage. That is also correct. So you have C option as the right one. Next is question number 153, which of the following is not correctly matched. So first one, butylated hydroxytoluene, antioxidant in food. Yes, this is antioxidant in food. The second one, chloramphenicol, antiseptic. No, this is antibiotic used for bacterial infections. This is wrong. C1 is wrong. Next one, northindrone, infertility drug. Correct. Elitame, artificial sweetener. That's also correct. So that means only the B is incorrectly matched. So that becomes our answer. Next is question number 154, which of the following is least reactive towards SN2 reaction? See, the order of reactivity towards SN2 reaction, order of reactivity towards this reaction is given by, first of all, you have methyl followed by primary halide, 1 degree, then secondary halide, and then tertiary halide, just 3 degree. Okay, so according to this, this option D, this is having a tertiary halide. That means, yeah, this is the weakest one. Option D is the correct answer because this is having a tertiary halide, 3 degree halide. Okay, so this is the answer to the question. Option D. Next is question number 155. Phenol is mainly manufactured from the compound X by subjecting it to oxidation in air, followed by treating with dilute acid. You have to identify the element X. See, the oxidation of cumene isopropylene benzene in the presence of air gives you cumene hydroperoxide. The reaction between the cumene hydroxide and dilute acid gives you phenol. See, let's write down the reaction. So here's your ring. CH, CH3, CH3. Oxygen 368 to 400 degree Kelvin, 400 Kelvin. This gives you this product. Here will be COOH, CH3, CH3. So this is your cumene hydro peroxide. Now this with hydrogen atoms, hydrogen ions, 323 to 363 Kelvin. It gives you acetone over here. Phenol first. This is phenol. So this, and you have OH over here, and this is your phenol plus CH3 COOH. This is your acetone. So that makes, this is the right answer. See, phenol is mainly manufactured from a compound X by subjecting it to the oxidation in air, followed by treating with dilute acid. So here is a treatment with dilute acid. First of all, it is subjected to oxidation. So this is the right answer, this one. This compound is the right answer. Option D is the correct option. Hope you understood this. Let's move to the next question. Question number 156, you have to identify A and B from the following reactions. These two reactions, first of all, like this is a multi-step reaction actually. First of all, you have butene, two butene over here. This is reacted with the O3 and then with zinc, and here should be water, H2O. It will give you some product 2X. And that when one reacted with sodium hydroxide dilute and then heated, then these two reactions are again carried out. You will finally get two products, A and B. You have to get those products. Okay. Now this is going to be a lengthy one. So, sorry. Question number 156, you have to identify A and B from the following reactions. So you have a butene, two butene over here. This one reacted with O3 and then with zinc, and here should be water. It gives you some product 2X. And that 2X, when first reacted with sodium hydroxide, dilute sodium hydroxide, and then heated, you get some Z. That Z, when reacted with O3 and then with zinc and water, again, it gives you A and B as a product. You have to identify what is A and B. So let's do the reaction. First of all, you have butene over here, two butene. This is C double bond. Here is H, CH3, the same thing, H, CH3. This when reacts with O3, it gives you, this is butene, butene, or this will give you monoozonide. That is given by C over here, O, and here you have CH3 and H, CH3, H, same thing over here. You have CH3 and H, monoozonide. Now, this is the first step reaction. Further, this reacts with zinc and water. So, zinc and water, this gives you acetaldehyde, CH3CHO plus zinc oxide, acetaldehyde. Acetaldehyde actually. Acetaldehyde. Okay, so now this is your 2X, this is 2, so this is your X. That means you have 2X as 2CH3CHO, right? Now this undergoes again some reactions. This is step 1. Let's go to step 2. In the step 2, you have that acetaldehyde, double bond O. This reacts with, first of all, dilute hydroxide, sodium hydroxide. This will give you C. Here will be H, CH3, OH group over here, CH2, CH double bond O. This is 3, hydroxybutanol. And again, in the second step, it is heated. So on heating, it will heat it. On heating, it will lose the water and will become butene to butanol. So C double bond CH, COH. Here will be H and CH3. So this is your butanol. Now again, the third one, it goes to reaction with O3. Now this is your Z. This one is your Z product. Again, it reacts with O3 and also will react with zinc and water, both the reactions together. So it will give me two products. The first one will be CH3, CHO, and this. This is ethanediol and acetaldehyde. So this is your A and this is your B product, right? And now let's see which is the right one. You have B option. This is the correct answer. Hope you understood this. Next is question number 157. What are the products X and Y respectively in the reactions 1 and 2? So this is the first reaction. Let's go and complete this one. This is the second one. Okay, the first one is OCH3 and you have CH3 over here in the presence of hydrogen iodide. It will give you this. So first of all, you have this ring and you have OCH3 on reaction with hydrogen iodide, hydrogen positive, I negative. It will give me this ring. This way. And here you have, so this is like this. And you will have, see, this H will join with this O over here. And O will be positively charged and here will be one H. Here will be CH3. CH3. This is phenoxide ion. And this further, when, see, this is when hydrogen is added, this will happen. And when iodide ion will be added, it will be like this. This ring and OH over here, CH over here, and this CH3I. This new bond will be formed, and this is your X. This is your X, the first one. Okay, let's go on to complete the second reaction now. The second reaction, you have this ring, and then you have this thing over here. So here will be C double O CH3 OCH3 over here. This on reaction with, it is being reacted with NH2, 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 potassium hydroxide, glycol, and heat it. This will give you this CHO over here. This is your Y. So this is this is X and Y, and let's see, they match with option A. So this is your right answer. Hope you got that. Let's move to the next question then. Question number 158, consider the following rich sequence. You have butene to butene, ozonolysis is done to get X, and then this particular reaction is done to get Y. In the presence of copper at 573 Kelvin, you get Z. So you have to tell the correct properties about Z. Before that, I need to know what is Z. So let's go with the reaction. Here you have two butene. Let's write it down. So you have CH, CH. This is CH3 over here. CH3, CH3. This is 2-butene, and it undergoes ozonolysis to give you 2 aldehydes. Here is X only, so you will write it as let's write it CH3, CHO. This is your aldehyde. This is X. Now it undergoes again the reaction with the methyl magnesium bromide and hydronium ions to give you Y. To give you, this will be CCH, OH, CH3, H3. This is 2-degree alcohol, and this is your Y. Again, Y undergoes a reaction in the presence of copper at 573 Kelvin. It will give you acetone. C, CH3, O, CH3. This is acetone, and this is your Z. Now you have to talk about certain properties of Z. First of all, it gives yellow precipitate with iodine and sodium hydroxide solution. That's correct. Next, it undergoes disproportion reaction in the presence of concentrated sodium hydroxide solution. No, it undergoes Wolff-Kirchner reduction. That's right. It forms red precipitate with Felling reagent. No, so here, first and third, these options are correct. See, the compound Z formed undergoes Wolff-Kirchner reduction, and it also gives off white precipitate with iodine and sodium hydroxide. That makes option D to be the right answer. Hope you understood this. Next is question 159. You have to identify the product Y in the following sequence of reactions. So this is the reaction. When reacted with sodium hydroxide and bromine, it gives you X. This reacts with C6H5COCl to give you Y. So let's do the reaction. I'll make it over here. Here you have the ring. And you have CH3 at this place, and C double bond O, NH2. Sodium hydroxide and bromine. This is called Hoffman bromamide degradation reaction. So here you will get the product as this. This will be the product. Here is a CH3 and NH2. This is 4-methyl aniline. And again, it reacts in the presence of C6H5COCl to give you this product. Here is CH3. You have NH over here, C6H5O. So it will combine, this group will combine with H, and plus you will have one HCl also. But mainly I'm interested in the Y. So main is the carbon compound. So you have this as Y, and this matches with. It doesn't match. It matches with this one. Let me check the D also. Okay, it matches with option C. Hope you understood that. Let's move to the next and the last question for the paper, question number 160. It says that propane anitrile and a propane anitrile, it reacts with lithium, aluminium, H. Question. The last question of the paper, it says propane nitrile in the presence of lithium aluminium tetrahydride gives you A, which in the presence of on heating in the presence of CaCl3 alcoholic potassium hydroxide gives you B. So the conversion of A to B is an example of which of these reactions? Let's complete the reaction. First you have CH3, CH2, Cn. This in the presence of lithium aluminium tetrahydride gives you CH3, CH 2CH2, NH2. This is propanamine. Now this on heating in the presence of CHCl3 and alcoholic KOH, potassium hydroxide, it gives you CH3CH2, CH2, NC plus potassium chloride plus water. This will be 3 and 3. Okay, so in this reaction, the propane nitrile undergo reduction on reaction with lithium aluminium tetrahydride to give you, let's write down in this reaction, propane nitrile undergo reduction with on reaction with lithium aluminium tetrahydride to give primary amine, that is propanamine, which is your A, which reacts with CHCl3 in the presence of alcoholic KOH to give you isocyanide, that is B. So this A to B conversion, this is carbylamine reaction. So this is B option. Students, hope you understood this, and with that we have completed all the 40 questions of chemistry section for this paper. And with that, don't forget to visit our website www.examsnet.com. For a better preparation of your exams, you must download our app. The link is available in the description box. So these things are a must for preparing for your entrance exam, because here you will find so many entrance exam question papers with their details, PDF solutions, and so it will be very better for your preparation. Students, keep studying, keep exploring, keep rising high. That's all for this paper. A very best of luck for your exams. Bye.